This week, we're going to be talking about Plan 9. It's a distributed operating system, and it's designed to make a network of disparate computers function as a single system.
So what's interesting about Plan 9 is that it has a single abstraction. It has the abstraction of writing to the file system, except that in Plan 9, writing to the file system is the way in which you persist data to a disk, but also how you write to the screen, read keyboard input, read mouse input, open a network socket. It actually just all boils down to files.
Hi, welcome to the Technium, where we talk about the edge of technology and what we can build with it, an optimistic look at the road ahead.
I'm Sri. I'm a YC alum and a research engineer focused on natural language processing for search.
And this is Will. I am also a YC alum, and I'm currently an independent researcher in programming language, but a man of disparate interests. So, hey, Sri, how's it going? We are on Season 3. Can you believe it? Season 3. Welcome back.
Yes. Thanks. It's good to be back. And welcome back to all of our fans. It's been quite a while, but we have a good season lineup for you.
That's right. And so this is the second episode in our Season 3, and so this time we are going to go back to what we do best, talking about different technologies that kind of perk up our nerd sniping interests. So what do you got to drink today?
Yeah, so this time around I have Gerolsteiner sparkling natural mineral water. I recently followed this. Yeah, it's kind of obscure. I recently started following this water sommelier on TikTok who insists that you can learn to appreciate the qualities of mineral water.
A water sommelier? Man, those guys must be so much better than wine because there's like nothing else in there. They must be so
I'm
sensitive
trying to
the
refine
stuff.
my taste here. It all tastes the same to me. It all tastes the same.
If we get accused of being hipsters, it's on you. So
there we go.
Maybe I'm not contributing. Yeah, I'm not helping things much either. I got something called Hey Tea, and it looks like it is, I don't know what flavor this is. Pear maybe? We'll see, but got it at the Asian grocery store. I think really a lot of times I'm attracted by the packaging, and like who knows what it's going to taste like, right? So
I think you bought it for that minimal design more than anything.
Right. If you can't tell, because it's I do like a lot of the spacing around stuff because it drives me crazy when somebody just like if there's a space they shove stuff into it. That drives me crazy. So so do you know what we're going to be talking about this week?
Well, you said nerd sniping, and I think we picked like the ultimate nerd sniping topic. So I'm pretty excited. Yeah, what are we talking about?
Yeah, I actually had heard about this for a long time on Hacker News and other places, but I never actually looked into it until now. And so, yeah, this even for me, this is something that I missed along the way. And so hopefully it's not too obscure, but we get the sense that there are a lot of fans out there, if not a small number of them. And so this week we're going to be talking about Plan 9. It's a distributed operating system, and it's designed to make a network of disparate computers function as a single system, regardless of where they are on Earth. And so you can see that the fact that I said distributed operating systems, it should perk up your antenna as well as the antenna of a lot of our listeners. And so if you haven't heard of it yet, we definitely encourage you to stay tuned, listen to what we have to say about it in our research, and then go play around with the stuff yourself. So yeah, that's what we're talking about today. Do you have a lot of experience with Plan 9 or anything yourself?
No, not at all. I first came across it in some research that I was doing into different end user programming environments.
Oh, really? Okay.
Yeah, like I think I came across it it has a text editor called Acme, which we might touch upon, but it has some interesting customizability aspects to it, and so I came across it through that. But yeah, I mean, it is definitely a very obscure operating system. It has a very fervent sort of enthusiast community who are keeping it alive, porting new types of programs and protocols and things into it and maintaining different forks and stuff. But it is really interesting because it comes from a very storied origin. It comes from Bell Labs, which is the origin of a lot of great inventions in computing history. And so this isn't just some Joe Schmo decided to build a distributed operating system. These are the people who were behind Unix and many of the great things that we use today. So yeah, it's super interesting.
Yeah. What's his, Rob Pike?
Rob Pike.
And
Yeah.
who's the other guy? They're both involved in Go. So
Yes.
like the Go programming language was their they worked on it at Google, I guess, in the mid 2000s, yes. But like before that they were working on Plan 9, and Plan 9 is what was envisioned to be the successor to Unix, and it's not backwards compatible with Unix, but they just tried to take the best ideas from Unix, and then based on a couple of things that they saw that were really good design principles for a distributed operating system, they took those and just kind of ran with it to see where it would go, and the result was Plan 9. And so as it stands today, it's mostly a hobbyist, if not researcher, and we'll get to talking about why that is even after all these years, because I think they first released it in the 80s, but like the non-commercial licenses weren't available until the 90s, and I think something like that. Like, yeah, so that's what we're going to be talking about today.
Yeah. So what makes Plan 9 unique compared to Unix or other operating systems?
So to start, one of the things that it has in common with Unix is that it treats everything as a file, and so that was the design of Unix that they felt that people got right, But then how it's different is that because it's a distributed operating system, it tries to build the entire system based on a foundation of two core ideas. One is that they have a per process namespace, which means that a particular user, when they get onto this distributed operating system, they have a local view of the entire system that is catered to them. And then the second one is that everything is based on a simple message-oriented file system protocol that they call 9P. And so based on these, they took these and just ran with it and adhered to it very strictly in the entire system, and see what sort of design or applications kind of like fall out of this design. Because in Unix, like it's, when things are more practical, I guess, you want to get stuff done, people like to do hacks, and it feels good in the moment, but then it ends up being a decision that you can't really go back and replace because everybody has adopted to this way of working, and people are just like, I guess this is just the way it is now, right?
Yeah.
And so Plan 9 was an experiment and research into doing a reset and seeing how our operating systems could be, especially if they were distributed.
Yeah. So in a nutshell, an operating system is basically a special type of program that controls access to resources such as devices, networks, file systems, and things like that. And so other programs that people run talk to the operating system and make these things called system calls, which say, give me access to this file, let me talk to this other computer over a network, et cetera, et cetera. And the interesting thing about Plan 9 is that it has a very limited set of system calls, or a very limited set of abstractions that it exposes to the programs that are running on it. So if you're used to programming on Linux or other operating systems, they have lots and lots and lots of ways that you can ask the operating system to do different things. So it has a special way to open files, it has a special way to open a TCP socket, it has a different way to write something to the screen, for example. And what's interesting about Plan 9 is that
are you talking about that they have a lot of different kinds of system calls, or that they have a lot of different subsystems to do one particular thing, or both?
I guess both, yeah. I mean, I think it depends on the different types of operating systems, but generally speaking, most operating systems that people use today have many different abstractions, let's say. They have a separate abstraction for writing graphics to the screen, which looks different than the set of abstractions for making network requests versus a different one for some other thing, right?
Yeah, writing to the writing to the file system.
Yeah, writing to the file system.
Right.
Yeah. So what's interesting about Plan 9 is that it has a single abstraction. It has the abstraction of writing to the file system, except that in Plan 9, writing to the file system is the way in which you both persist data to a disk, which is how you typically think of a file system, but also how you write to the screen, read keyboard input, read mouse input, open a network socket. All of these things are actually wrapped in this abstraction of files to which you can, send messages or write things and read things from. And so that's the super interesting thing, is that it actually just all boils down to files.
Do you know why, as an aside, like why our current Unix and Linux systems have a different abstraction for each of these interfaces? Was it just that when we said file, like because we called it files, like we thought that was for file systems and definitely not a good abstraction for networks, or it was kind of a thing that we found retroactively that, oh, maybe this does work?
Yeah, I mean, I'm not super sure. I'm not like a OS researcher, but I would imagine if somebody asked me to write an abstraction for, graphics, right? Like Microsoft hired me and said, write a graphics subsystem for Windows or something like that back in the 1980s or something. I would probably, it would not occur to me that I should represent this as a file. That's not the natural abstraction of graphics, right? Like,
right. You wouldn't say like, let me grab the file from my back pocket and slap it on this graphics thing. Yeah.
Exactly.
Yeah,
so
definitely.
I would think in terms of shapes and buffers or whatever, like pixels. So it is definitely a sort of requires some mental gymnastics, right? In order to...
A little bit of squinting, yeah.
Yeah, right.
Yeah,
like
so...
In order to be like, oh, we should do this, yeah.
Yeah, if any of our audience members or like listeners know why we got the system we did rather than the one that we planned for, maybe, then let us know in the comments, because I'm definitely curious about like how that is. Because a lot of times I get the sense that the systems that we do end up with are nothing like the ones that we would if we design them again with experience. But because like the systems are so successful and so pervasive, like it's just nearly impossible to like get these conventions changed and replaced, which I guess we'll talk about that a little bit more later in this episode. Yeah, so going back to the big ideas in Plan 9, one of the things that it talks about is a per process namespace. We won't get into this too much, other than to say that because it's a distributed operating system, you want a way for people not to clash when they're trying to access resources. Because like you just said, one of the main jobs of an operating system is to control and gate and divvy out resources to people. And so when they have namespace clashes, that can be a problem. And so in Plan 9, one of the things that you have is a namespace that references all the resources you have on the network, but it's local to you. And so as an analogy, consider the difference between the phrase my house and the precise address of someone's home. So while the latter one, the precise address, can be used by anyone, the former is like easier to say. It makes sense when it's spoken, and so and it changes meaning depending on who says it, so it doesn't really cause confusion. And so in the same way, like devices that are represented by files in Plan 9, because everything is a file, even devices, like it always refers to the user's terminal, right? And so it's basically like the same way as saying my house or my terminal, or like the date is always the correct version of the date command to run, and stuff like that, specific to the architecture or whatever it is that you need for your local thing. And so it's these like local conventions that guarantee sane behavior, because otherwise you would have to know the global name of everything in a distributed system.
Yeah, so if you're used to traditional operating systems that you might use, like Linux or most Unixes, the file system is a single monolithic thing. You mount it, it's globally available. There might be permissions on the directories and files so that a process might not be able to read everything, but everything is in a single directory structure and a single namespace. And this is in contrast to Plan 9, as you were saying, where each user and each process has its own view of the file system. And so Plan 9 exposes these commands called mount and bind and unmount. And so when a process starts up, it gets to decide, I want to mount the network, and it mounts the network, and it gets its own personal view of the network file system in its namespace, and it can mount some other resources, and it will get its own view of those as well. And so, yeah, like you were saying, this kind of solves the issue of having to have some type of global identifiers to prevent, collisions between resources and things like that. Instead, Plan 9 solves this by having each process mount its own view of the resources into its namespace.
Yeah, and what's also interesting, based on my shallow understanding of the system, in that I haven't used it myself, but from what I've read and researched is that you also have a lot of control using these like commands with like mount, bind, and unmount, in which you can control where the computation was happening, like whether it was on your machine or some like other machine somewhere else, because the system isn't just a homogeneous set of machines that you can just run anything on anywhere. Like there's specific services that are running on different machines, so some might be more apt for a job than others. So you can actually have a remote machine be the one that's running the computation and the storage actually being somewhere else. And so it's up to, like, you have control over the orchestration of this sort of stuff, which makes sense in a distributed system.
Yeah, I think with that, it makes sense to sort of go into what are some of the unique and interesting ways that Plan 9 exposes different types of resources that we would normally think of not as files, but exposes them as files. What are some, interesting ways that it makes use of this abstraction?
Yeah, this is the meaty, juicy part of the thing. Like when we talk about the design principles, it can be kind of hard to grasp that because it is the amalgamation of people's pattern matching. So you don't know like exactly like what happens when you kind of adhere to these principles and then just kind of carry them to their logical conclusion. And so to give something more concrete, one of the main things that distinguish an operating system is that it's has a file system. And so it's so basic that we almost often don't talk about it anymore. Although, as an aside, have you read recently that there are like some youngins on the internet that don't even know what files are? Right? Because does that surprise you? Because, well, as an aside, like a lot of the unit of compute, I guess, is an app nowadays due to like mobile phones. Like nobody's talking about like sending files over the network or anything like that, right? You share a document at best, but like you send it to people. So a lot of times like these younger users of the internet, like they don't even have to be programmers, but this also includes programmers, like they just don't know what a file is. And so that can be surprising to those of us that have been around for a little while. Bizarre. So anyways, back to file servers in Plan 9. Like I said earlier, there are heterogeneous services on the network. And so some of them might be more conducive to being a file server because they have more storage or because they, are bigger machines and whatnot. And so in Plan 9, they have something where they refer to as a dump file. And it's basically a history of all the files in their states in the past. And they, like every node that has their own view of the file server would sync it to the file server so that the things can be backed up. And it's not just the current state, but it holds the entire state of your file system now and in the past. So it's a little bit like Git for your entire file system. And so what falls out of this is that there's also no backup system because the system already by default already has backups. But even more surprising to me, I guess, is that because it adheres to the Unix philosophy of everything as a file, you can actually attach your running process to a part of the dump file so that you can do compare and contrast. Like you can use that as a source and input into the other applications that you might use, like a diff or something like that. So you can potentially run like last month's compiler with your library today and see what the differences are, like through your entire file system. Like you don't need specialized tools like Git in order to do things like that. And so that's something that I thought was pretty neat. But one of the things that you said, like we're kind of used to network resources, but we still don't have like versioned file systems today. It's just really not common. Like our databases don't support it by default, and like most people don't have versioning other than, I guess, developers. Does anybody else have it? I mean, you kind of have it in Google Docs and Google spreadsheets, but it's pretty cumbersome. Yeah. It doesn't feel natural.
Yeah, and these are all implemented in userland. But yeah, I think it's super powerful to have these things baked into the operating system because then you can just rely on them and also have a unified way of having versioning or backups and things like that.
Yeah, because if they're primitives, then you can find new ways to use it and you don't need to reinvent it yourself. Because like nowadays, every application that needs some sort of versioning will try to do it themselves, probably poorly. And so they just won't do it. So having something like that, I think would be really powerful. And then as a second concrete example of what Plan 9 lets us do, is that everything is implemented as a file server. And so surprisingly, one of the things that's also implemented as a file server is the windowing system. And for those of you that use Linux and Unix, like usually the Windows system is like a separate thing. It's not considered part of like it doesn't have like a file interface. And so in Plan 9, the windowing system is called 8.5, and it has the power to postpone read requests from any particular window because it's a file server, right? You can just postpone the reads. And so you can toggle this on and off with your keyboard. And because you can suspend it, that means that you can type in a whole bunch of stuff in the keyboard into the window, and it won't be sent to the application until you're all done with it, and it resumes. So you could use it as kind of a makeshift editor for composing email. Does that make sense? So like you don't need to, if you write an application in Plan 9, like you don't need to bring all your toys with you, because like some of the basic primitives in Plan 9 will help fill the gaps by letting you suspend things. So then like you can just keep typing stuff, and lo and behold, it's an editor, right?
I see. So basically, like if you were to make a GUI today, let's say it's a new type of email client.
Yeah.
Every time you make this, you need to bring in some library which has text editing capability and handles all the things, line breaks and whatever stuff that you need in order to have a text editor. But you're saying that this is sort of, comes with the windowing system, and so you don't need to necessarily. You can fall back to this rather than having to implement this every single time for each application.
Yeah, but I think deeper than that is that Plan 9 found composable abstractions to represent these resources and how to interact with them. And also, they didn't keep it for themselves. They provided it to you so that you can do these things and come up with new ways to use them should you find them. And so I think that's one of the interesting things about Plan 9, right?
Yeah. I also just want to step back and say there's probably interesting details of how Plan 9 implements and exposes the windowing system, but it is like really bizarre to imagine that a windowing system is exposed as a file system and that you can just talk to it like you would normal files. If you write any type of program, actually, like when I was learning to program, there was this big gap between when you would write some crappy little script that you would run in a terminal and it would print like hello world or a little calculator or something. And there was a big gap between that and real programs which ran GUIs, and they showed windows and they would show things. And actually, from a programming perspective, there is a big gap because you have to import whatever the operating system library that opens a window and draws things. And each operating system has its own library like that, but they're all really complex. Like you need to really learn those things. There's quite a lot of abstractions that you need to learn.
Did you ever try Windows programming like from way back?
I did. Yeah, I did.
Yeah.
And
I thought I was just like, oh, maybe this. I don't know. But like since then, like I to be honest, I haven't done a lot of like desktop application programming. Since then, I'm just like, let's just do the web. It has its own share of headaches, but that Windows programming is difficult in its own way, if I were to be diplomatic about it.
Yeah. I'm sure that it's a particular type of mess, but even regardless, like even in the most ideal world of GUI programming, if such a one exists, there's still this gap between writing your first little scripts and then actually showing something to a window.
Right.
And so it's really interesting, actually, that Plan 9, if you can write to a file, you can create a window and then render something to it, et cetera, et cetera. And what I found really interesting about Plan 9 in some of the talks that I was listening to was that a lot of the programs that you'd think are really important programs were actually just like a shell script, basically. So they just use the scripting language to open some file, write some stuff to it, but this thing was like a web browser or something. Like it was actually like making network requests. It was displaying the things to the screen, and this is completely unthinkable. Like if you were to try to write a GUI in Bash, first of all, I don't even know if you would be able to do it. But second of all, if you did it, it would be the most convoluted way to write such a program. But in Plan 9, because everything's a file, you can basically just script your way to like pretty interesting applications.
I think React has a target for like UI programs, TUIs. I think so. Yeah. So it is possible. People are doing it, like some version of React Native or something like that. But I get what you're saying. It's kind of like the thing that I was talking about before, and we might have touched on this in end user programming episode that we had back in, what is that, season 2?
Season 2, yeah.
Season 2, yeah. End user programming, where like you design the system, but you provide the building blocks that you as a system designer use to build the system to your end users, and they have as much power as you do to configure their system the way that you do. And so a lot of the power comes out of that. And I think Plan 9, it probably falls along the same line, so that you can do these seemingly powerful things that would be really hard to do otherwise in other systems, or just the systems that we use pretty much today. So I guess the last concrete thing that we'll cover is that, like, for example, there's no FTP command in Plan 9. Like, instead, what they did was they effectively wrote a wrapper around FTP so that you could mount an FTP as a resource in the file system, and then you can use all the regular tools that you usually do, such as like ls, diff, grep on that. And so in that way, they cut down on the things that you have to do a lot. And so this follows from principle number 2, where like they just use the simple messaging, or like the message-oriented protocol. And so it takes a little bit of work to kind of convert an FTP connection somewhere to this thing, but like it's apparently well worth it, because then you can just leverage all the same tools. And so I think this kind of relates to the principle that I've heard Rich Hickey talk about, like he's the inventor of closure, in that like object-oriented programming had the promise that we would have a lot less code and we would have more reuse of code if we use object-oriented programming, where, you know, we had data and then we had the methods that operate on the data there at the same time. But for a variety of reasons, it didn't really kind of work out that way. And so what Clojure seems to have done is they've had a whole like a few number of data structures that people know well, and then just a plethora of functions that operate on it. And so if you can get things into one of those data structures, then you have like the universe of these functions to operate on them, regardless of what's contained in them. And so in that way, you can reduce code size and reuse, because a lot of these methods are operating on these generic data structures without really caring about like what's in them. And so I think Plan 9 is similar in that way. They found like a couple good abstractions that does most of what you want throughout the entire system. And so you have access to it. And so anything that you can get into that shape, then you can leverage the rest of the ecosystem's tool for it.
Yeah, you know, to make it concrete, I think that a lot of times I use apps and I wish they did something just a little bit different, but I can't get them to do that thing. Like, for example, I have like switched between lots of note-taking apps because only some of them support like syncing to Google Drive or something versus like syncing to iCloud and stuff like that. And it's really disappointing because, like you said, presumably writing files to Google Drive is more or less similar to writing files to some other type of cloud service. Maybe you need an abstraction layer to take the writes and translate them into whatever other API calls, but it's theoretically possible, right? But we don't have the tools. We don't expose the tools at the operating system level today that you have this type of interoperability. And I think that, you know, not just FTP, but there may be a variety of different types of network protocols that if you were to write it once in Plan 9, they would be able to be used by a variety of applications, maybe even agnostically, right? Like the program doesn't necessarily know I'm writing over FTP or I'm writing over SSH or whatever.
My impression is that it doesn't care. Yeah, so Plan 9 is a pretty interesting system based on some of these concrete examples that we talked about. It works in ways that we don't expect people to be able to use it with like what the computer systems that we're used to commonly today. And so we know that Plan 9 is not super prevalent or popular. It's obscure to even us. And like we look at all this sort of random things. And so, but like, what do you think is its significance? Like, if it were to be more pervasive, like what are the second and third order effects if like it found like common adoption, or like where do you think its like good niche could be?
Yeah, I was reading on Hacker News people discussing Plan 9, like people who have used Plan 9 discussing the implications of Plan 9 and why they're excited in keeping this thing going. And somebody mentioned this idea that you can actually get like 80% of the way towards Kubernetes using Plan 9, because Kubernetes ultimately is a different type of operating system over a set of computers, and it provides some abstraction over them and abstracts the processes that run on them as well and the resources that they provide. And so if you think about it, that's what Plan 9 is doing. It says you can mount all of these disparate resources that are spread across multiple different physical machines together into one view, like a holistic view, and then you can, mount them into programs. And so you can actually mostly get there via Plan 9 and maybe some other special sauce to handle high availability. But Plan 9 is pretty powerful in that sense.
That's pretty interesting. Yeah, I didn't read anything about how Plan 9 does multi-node or availability or anything like that, but
yeah, I looked a little bit into this, and if you read the Plan 9 paper, the original paper by the authors, which is super readable, by the way, and I recommend everybody read that, it does make some assumptions. It shows the ideal setup of a Plan 9 environment, and it makes some assumptions about the fact that they're connected together through particularly reliable or high bandwidth link, like Ethernet or something like that. And it does work over TCP and things like that, but it relies on TCP to be reliable. And if TCP fails, then a lot of these things fail. So it's not.
That's a lot of things, but yeah.
Yeah, that's a lot of things, right? And so I think that at the time when they were designing this, that was the state of the art, right? Distributed systems as such were probably not a very prevalent type of discipline.
Yeah. People's radars, but it was considered relatively researchy and fringe at the time, I think.
Yeah, exactly. So I think that some of the people in this thread were discussing that you could add, rely on the primitives that Plan 9 provides, but then add other types of failure recovery systems or leader election and things like that, just at the user space level. But yeah, I thought it was interesting, just the idea that a lot of what we're building today in things like Docker, Kubernetes, and all of these other cloud abstractions is we're trying to build a cloud OS. And what if the OS, just your normal OS, was a cloud OS? And, Plan 9 predates the cloud, but it basically is something toward that.
It would make deployment much easier, I can tell you that.
Yeah.
No, I mean, as an application developer, for the web, I don't enjoy doing DevOps at all. Because it's those things that I only do once and then I never remember. And then if I don't write notes for it or make it automated, I'm I don't remember how to do this. And so, and then a lot of these settings and configurations just seem so arbitrary. There's not a lot of concepts or principles that you can take from program to program or system to system, unlike some of the other things in programming. And so I'm just and so if systems were more like Plan 9, even just like you said, writing to files, that's something that you often do as a programmer, and you might have to look up a couple APIs here and there, but for the most part you understand what it is, and so you'd be able to accomplish a lot more if the interface was similar. Yeah, I can see that being a lot better that way.
Yeah, I think even people who are full stack, they are full stack by sort of brute force, right? You force yourself to learn all these things.
Yeah.
You're not just naturally full stack because somehow all of the things you learn allow
build
you
on
to
top
translate.
of each other either, right? They don't translate, they don't build on top of each other or anything like that. Yeah.
So I thought that was interesting, and I think that you see this a lot in this ability for translatable skills and abstractions that build on top of each other in these researchy operating systems or principled operating systems and environments that we've covered before, Smalltalk. We discussed where you could inspect running processes and do these things that you'd think of are in the realm of compiler programmer type things or dev tool programmer type things.
Yeah.
But you could just do them really easily because there's this abstraction which you already know and understand, sending messages to objects. And I think we also saw this in Unison as well, where it has this nice content addressable abstraction, and that this allows you to do other types of interesting things that would otherwise be hard in other languages and other programming environments. And so I think
and so for those of you that want to look into it, we cover those in season 2 for Unison programming language, and also the Smalltalk, which were two of our more popular ones. So I definitely encourage you guys to go check it out. So, but yeah,
indeed, yeah. So yeah, if you like this type of operating system stuff, definitely go check those out. Yeah, I think in general, all of these things, what they have in common is that they have this one abstraction, and they just decide we're going to take it all the way, to its logical conclusion and impose it basically on everyone. And by imposing it on everyone, by being principled and saying this is the way that this is done in the system, and there are not all these other alternative ways to do things, you can have tools that rely on each other and build on top of each other.
Yeah, and it seems like that's actually quite hard to do, right? Because like everybody has deadlines in a practical system. They're just like, we'll just do it, whatever. And I guess on one hand, you get things done and you're making money and your product's out there, and that's not nothing, right? Your product's out there, people are using it. But on the other hand, you create this pile of garbage for like every programmer that comes after you to have to like waste their life with. And so maybe that's the price we have to pay. But like, I don't know. Yeah. So I mean, I'm still a little bit split on it, because like on one hand, like you do have these crappy systems that go out, and once you have seen enough of them, you just get really tired of just having to wrangle yet one more arbitrary thing that some other guy decided, and it just doesn't fit with whatever your problem you're working with. And so you have to learn these arbitrary things as you go from like industry to industry, or like part of the stack to part of the stack. But on the other hand, there's been plenty of instances where people build clean systems that nobody uses. And I mean, if nobody uses it, then it's hard to do any number of things in the world with it. Like you can't convince your peers to use it, because your peers are like, I've never heard of it, nobody else is using it, there's no conferences, I can't get swag about it, so why would I use it? Or like, I can't convince my boss because they're like, we can't hire people for this, so why would we use it? That sort of thing, right? But then I guess the only shining light I can think of right now that has stuck to their guns and yet has achieved some amount of commercial popularity is Haskell. And so for those of listeners are thinking, if Haskell is your example, then like forget it, right? But I think Haskell, like they've been relatively principled. Like they have stuck to pure functional programming for a long time, and it's been a slow failure upwards, but people are using Haskell in production. I mean, Hasura is a relatively successful company, and they are well known to use for using Haskell. What do they provide? Like a GraphQL database that you can throw on top of a Postgres database. So they're doing pretty well. I've used their stuff. I like it. So so many spot like unsponsored ads for
unsponsored ads. No, but I think Haskell. Haskell is a good example of a principled, research-oriented programming language, or just any type of software that has managed to find some success. I mean, enough success that like there are jobs, there are real jobs that people get paid to write Haskell, which is more than many actually more than Plan 9 can say, right? Like, so but I think that Plan 9 is interesting because it's also very rooted in this like principled research oriented environment. But they made the explicit decision not to be compatible with like Unix and that whole ecosystem, which helped in developing this abstraction, but it also hindered the use of many of the common programs. So like Plan 9 doesn't have Emacs, it doesn't have Vim, or people had to port those later if they exist. And so that hindered it. But I think that, I think that might have been more of a hindrance back in the day before the cloud, when the type of operating system that you used had to have everything. It had to support GUI, it had to support all these programs, et cetera, et cetera. But nowadays, in this cloud world, you kind of don't really care. Like as long as you can package up your program and send it to this OS, and it can, it provides compute and other abstract resources, it's a viable operating system, right? And so maybe Plan 9 can be the cloud OS, and maybe it's never going to be the desktop GUI OS of everybody, but it can find its niche somewhere.
Well, I was going to say it also has no modern web browser, and so that makes distribution for like things. It may not have everything, but it also does not have a web browser, so it makes it difficult. I think they have some like sort of like Link's equivalent of a rudimentary web browser, but it's obviously not a focus of their community. I was thinking that like you were saying that it could be a replacement for Kubernetes, and that's an interesting thought, because cloud is a big thing. It makes people, the big tech companies, a lot of money. But like if part of the reason is because just dev is so complicated, you just want all that instrumentation and like things to be pre-set up for you. But if DevOps was a lot easier, then maybe it would obviate the need for these sort of cloud services, and you can just kind of run things by yourself. And so that's a pretty enticing thought if Plan 9 ever took off. One of the quotes that I've read about Plan 9 from this guy from Microsoft, I should know his name, Raymond something. We'll post it in the show notes later. But he was saying that Plan 9 is different enough, but not so different that it could do things that Unix was already doing 10 times better. And so I think this is just the nature of new things. Like you really need to be order of magnitude better at some niche that the old thing isn't good at, even though like it's not good at anything else. And so I don't think Plan 9 has found that quite yet, or people haven't like found a match. But if it does do like cloud deployment and like Kubernetes thing, like people are looking for like a Heroku replacement. If it could actually run like workloads that people can write in different languages, maybe that's a niche there.
Yeah, actually, I just had a crazy idea. So
bring it.
Yeah, that's what this podcast is for. So WASM programs, WebAssembly programs, like have now like there's a working group that is trying to create this API called WASI, which is the set of abstractions that are available to all WASM programs, such that they can run on servers and not just in the browser, but so that this is the way by which WebAssembly programs can read from the file system, they can make network requests, etc., etc. Now, what if you had a Plan 9 WASM OS, and all it did was it had files that were exposed through WASI, and so if a WebAssembly program can read and write files, it can now do everything. Like you don't need to develop WASI even further because you just mount different Plan 9 file systems that maybe provide graphics, they provide file storage, they provide FTP, etc., etc. And now the world is your oyster, right? And so, and it can also be the way by which you deploy the WASM programs as well, because you can mount the cloud services and send your compute over there and whatnot. Like this is just like a magic OS now.
Yeah, maybe. I don't know enough about Plan 9 itself to know how valuable it is, but like on paper, it sounds interesting enough to look into, because I think, there's a lot of excitement around WASM and deploying various number of applications as WASM files so that they can be portable across different systems, not just through the web. And so you could conceivably have something like that as a way to simplify deployment. So yeah, I mean, it'd be worth looking into whether anybody's already trying this sort of thing, because there are definitely clones of Plan 9. Like you don't have to use Plan 9 itself. There's plenty of clones that people have been doing. So maybe one of those would be more conducive to, like, instead of using containers, using WASM.
Yeah, and the other potentially nice thing is that you don't need, because WASM programs can be written in any language, you don't need to have the same library repeated across all the different languages in order to interface with the different resources that are available on your OS. You can just mount them as files, which basically every programming language can do.
Yeah, it's narrow waist all the way. Everything is a file. Everything is WASM. Yeah, I wonder. Yeah, that would be worth looking into. So listeners, if some of you guys out there are looking for a project to work on, this could be it, or another startup. We're full of that. Indeed. So yeah, I think that's definitely an interesting take. So like I think it would also be interesting, like one step further is that this intranet, this like distributed system, was not only available to developers as a way to deploy programs, external or internal, but like it would also be available for like end user programming, in the same way that like spreadsheets and Airtable is usable for people that are non-technical. And so Plan 9 is a little bit of reach because like, command line GUIs and stuff like that, it's a relatively high learning curve for people that aren't technical. But I was thinking that you could provide a word processing file for people that are non-technical to kind of type the equivalent of HTML back in the day, right? Like people used to, like, that weren't super technical, they were able to get jobs doing web design because people were typing in HTML. And so you could conceivably do that. But then look at where the state of the web is now. Like we have transpilers compiling our HTML for us, and so maybe we'll end up getting that state no matter what. And so maybe that's not the case for Plan 9 because it's just nobody has a vested interest in it. So yeah, I don't know. But I was thinking of it as like an intranet for people to like deploy applications on, because like everybody is more or less a trusted user, maybe, I guess. And so like it's kind of the way that time sharing used to be. But now
Yeah,
we just
actually,
have like networks with public networks behind like a lot of security where we deploy like internal apps for our like processes, or we outsource it to like Google or like, for Google Docs and
right.
stuff like that.
Yeah, yeah. But this idea of having an intranet you just like can reliably perform all these operations on is interesting because it
I
kind
was
of
thinking
reminds.
like you can get internal applications on, so like your
Yeah.
like HR or like interview tracker or something like that, and so you
Mhm.
could get those deployed internally to help you with your like company processes.
Right, and you can access those programs pretty
Yeah.
seamlessly. Yeah.
Rather than like just general compute. But anyways, go on. You were
Right.
saying.
Yeah, yeah, yeah. No, I think what's interesting is that this somehow vaguely reminds me of local first
Oh
programming that we
yeah,
talked
our
about.
favorite.
Yeah.
So to
And
recap, I guess there's a lot of references. We talked about WASM, I think season 2, and then
season
local
2,
first programming was in the first season.
season
So you
1.
got to dig. You got to
Yeah.
dig in the archives for that. But yeah, definitely go check those out.
Yeah.
But yeah, what about local first programming or
Well,
local first
so
software?
yeah, local for software. So in local for software, to recap it, it's this idea that you can have programs that operate, they store and manipulate data locally, but then this data gets synced to other users across the network.
Uh-huh.
And so, I mean, this seems like if everybody ran Plan 9, it would be really, really cool because you would be able to get local for software for free, because what you would have to do is write some kind of wrapper the same way that somebody wrote the FTP wrapper over the P9 protocol. You'd write maybe some type of CRDT wrapper that by which programs would write to a local file, and this would get translated into CRDT operations. And not only that, but you get this sort of networking for free because you mount the peers with whom you're sharing this data, and then you get this like networked CRDT backed file system or file server that then any program can just write to.
So are you picturing this as like a tuple space of some sort, like or like a like any application can write to it, or just like a file system where like anybody can write to it and it'll sync? So you would I guess like there would be a file in the file system that would be considered the company's wiki, let's say, right?
Yeah.
And then you just write in there, and then it'll just sync to every other machine no matter where you are on it. Yeah, I don't know too much about Plan 9's like file syncing thing, because like you get your own view, but like is it automatically synced in real time to every other user, or is it like locked? That I don't know.
Yeah, I mean, I think you can the when you write the abstraction, like the FTP wrapper over, Plan 9, it exposes like there's some logic, right? So like it translates the reads and writes to the files and translates them into the FTP protocol. Similarly, I think that if somebody wanted to write a CRDT protocol, they would translate the reads and writes to that file and decide whatever conflict resolution.
I see. Right. So then from your point of view as a Plan 9 user, you would just use all the regular stuff. Like it would just look like local files to you, and you would just like ls, diff, grep, or whatever it is, and you can just move them around. And then underneath, like whatever that like wrapper for CRDTs are, it can just sync to whatever system, whether it's within Plan 9 or even external systems that are using this sort of thing, right?
Yeah, exactly.
Yeah, that sounds like a tuple space of some sort. Unlike our other things, we might have to do something like that. Tuple space. Real quick, it's like a distributed systems idea from the 90s that hasn't quite caught on yet, or there's been a lot of work on it, but it's not super popular today. But yeah, it does sound a little bit like a tuple space, which is interesting. It connects to some of the recent work people are doing in the thinking tool space, where they found that instead of using messages, it might make more sense to have like a effectively shared memory, I guess is a way to put it. And we know that there are issues with shared memory because like locks and stuff like that, but some people are like thinking, could we get away with that if we serialize the writes so that the writes are still one by one so they don't trample over each other, but then you have a version history of the entire data so that the reads don't block each other either. So you're always reading like a specific version, so you don't have to block on reads at all. And so there's been some work along that lines, and this sounds vaguely in that direction where I don't know, I guess after a while like a lot of stuff starts to look like each other and like I'm surprised at how many good ideas people have taken in the last couple decades, and we're basically just like rehashing some of this stuff
Yeah.
in new ways. Presumably, it's not a pendulum, but more of a switchback where we're going higher and
Yes.
higher, right? So
Yeah.
yeah. So I think the Plan 9 has a potential to kind of turn the idea of how applications are delivered, or like how an intranet or like a system, because like oftentimes we conceive of a computer or a computer as a room, like we did in the dynamic land episode back in season 2, like compute somewhere out there in the cloud. And so usually we think of it as public clouds maintained by some central thing. And here Plan 9 is also has a central administrator, but it's considered more of an intranet rather than an internet, because like I've always found it kind of weird that Google has it runs Google Docs, and like more than half the companies in the world store all their like processes and secrets on there. Like I don't know. So I'm sure Microsoft doesn't, but like does Facebook use Google Docs?
I don't know, but yeah,
I don't know,
it is a risk, I suppose. Yeah.
But presumably Google knows well enough that if people tried to look at that, people just won't use their stuff, which is bad PR. So.
Yeah. Yeah. Yeah, but yeah, you're right. Like with a sufficiently powerful operating system that exposes a lot of these services as network services and exposes a lot of this functionality that we typically think of as being only provided by the cloud, you could keep a lot of these things internal on your intranet. And then maybe you wouldn't have this trade-off of what is like on-prem versus cloud type stuff. And this used to be a big debate, but like, and the trade-off was always that like the cloud had all these advantages because you could rely on all these services that were native to the cloud. But yeah, maybe your on-prem stuff could too, assuming you're running Plan 9 or a similar operating system.
So how do you think we would actually get to that sort of world, as a quick aside? Because like I just don't see it, because like the current internet is pretty good. It's not bad. Not bad for the end users. It's kind of terrible for people that are working on it, because and sometimes we don't realize how terrible it is, because we think that we take it for granted that all these disparate things are disparate for their own reason. I don't think a lot of us stop to think about it, but but I don't know.
I think that the optimistic view is that, you mentioned the narrow waist, and the narrow waist is this idea that if you provide an abstraction onto which all the users map themselves, then you kind of cement that abstraction in the system, right? It becomes this sort of choke point that everything relies on. And so I think how do we get to this view of like this nice clean abstraction versus all these disparate abstractions? Well, I think that if you have programs that are relying on this narrow waist of WASM, and CRDTs become the narrow waist of data syncing rather than all custom data syncing protocols and things like that. And like presumably in that world, then you could say, hey, I have this operating system which is going to be the narrow waist of resource access and allocation, which is Plan 9. Like once you sort of serialize everybody on a standard way to, package programs, talk over a network, and then run on a operating system, then you have this magical world. And I know you're laughing, and as it comes out of my mouth, it sounds like a utopia. But
well, it sounds like an XKCD comic. So
right. The standards, yes. But I think we're getting there, right? Like Docker very quickly has become this abstraction of representing programs, right? And Kubernetes has increasingly become the abstraction of the cloud operating system. How do you represent your cloud? And so I think people are getting fed up, and they're like putting things in these abstract boxes, right? And saying, imagine everything is homogeneous. And so it's not out of, the realm of possibility that somebody would look at the operating system level itself and say, well, why don't we create a narrow waist for this as well?
Yeah, I want to say my take on this is it has to be some sort of like market condition where like Plan 9 ends up falling into some sort of niche that it's really well suited for, that people start wanting to do. Like, but I don't have a real clear idea what that is, and so maybe it's just like, the closest thing I can think of immediately is just like easier dev deployment. And so if there was like an easier story where you can, maybe it's just what you said already. The story is you can deploy anything on this thing through WASM, and then the deployment story is really simple because it's Plan 9, and that's pretty much it. And because it's on like a cluster that you run, like nobody else needs to be compatible with it. You can talk to the outside world like via the typical web protocols, but like internally everything is a file, and you just like mess around with it and get it up and running, and that's about it. And yeah, I don't know, maybe that's the story. I'm not sure. Yeah, so if those of you listening have like a better story about this, or you can envision a future where like things would be so much better if everybody ran Plan 9, like let us know in the comments. Like we'd love to hear that. Yeah. So then, is there anything else that you wanted to like mention about Plan 9 that surprised you at all, or like it's kind of like a particular insight to Plan 9 itself?
No, I think that it's the abstraction is really great. I think that I read some experience reports of how like people like have used this. And so I would say to our listeners, if you're really intrigued by Plan 9 and you want to go use this thing yourself, it's quite different than most operating systems that you're used to in terms of its UI affordances and things. And so
it's like learning how to walk all over again.
Yeah, exactly. It's like the way that it scrolls, the way the mouse works, all of that is super, super different. And so it's very intimidating sounding, is what I'd say. I was surprised by how much of a different world it is. Like it's not just a nice little new abstraction, but it feels very similar. It's like a whole other world. It's like learning to walk again.
Well, for those of you that are too cynical saying everything is all the same again, maybe this is the thing for you, right? So open your eyes to being a newborn again to technology.
Indeed.
So maybe there is a little bit of that. So I'm pretty excited about the future of Plan 9. It's going to be something that is doing a low, slow burn in the background like Haskell has been for the last couple decades. And I'm pretty sure somebody will find inspiration because I think the ideas behind it are actually pretty powerful. Like Plan 9 itself may not succeed, but I'm pretty sure we'll find some successors there. What about you? How are you feeling? Optimistic or something else?
I think the conditions that Plan 9 was designed for, which is this sort of homogeneous intranet type environment that you were talking about, or like centrally administered intranet type environment that we're talking about, is sort of re-emerging again, I think, with the cloud, and right, so you control all the programs that run on it and how they're connected and things like that. And so I would encourage people to bring back Plan 9 with a new cloud twist. That's my sort of call to action, and I think it could work this time.
Yeah, I'm pretty optimistic and excited because definitely we are all distributed engineers now. We just don't know it, especially web programmers. So the more inspiration from well-designed systems we can get, the better, right? So that's great. So with that, this is Will, and we had a great time talking about Plan 9 with you. If you want to check out our past episodes, the ones that we mentioned, they are on our YouTube channel or on our Spotify, and we are also on Twitter. My Twitter handle is at IAMWIL, which is I am Will, and you are?
It's going to be overlaid over here, so just
oh yes, we should do that, right. We'll do that instead, and we'll point down here. So like follow us, and we have plenty of other things to talk about in our future episodes, and if you catch little tidbits here and there, you might get a hint as to what we're going to talk about next. So this is Will,
and this is Street,
and we enjoyed having you here at Technium. We'll see you again next time for more episodes of technology. Yay.
See ya.
See ya. Bye-bye.